Hello, welcome to the Devoptimus Prime class project for the fall 2015. Let's get started on milestone 1, the build server. So we have a GitHub repository with post-receive webhook. Every time you push a change, it gets built on a Jenkins CI server, which indicates the management of that build. So here we've pushed to broken branch. Notice a build number 33 has started on that origin. We can check the console output to see that it's finished in failure. Therefore, we have also received an email indicating the same logs. Milestone 2, testing and analysis. Here is a TOX report that generates code coverage across our entire code base, with each module being highlighted. Now we can increase the testing with the hypothesis tool to add some more variability to our testing. Notice below that we've increased the code coverage from 24% to 45% with some test fuzzing. For base analysis, we use Flake8. Flake8 allows us to write specific plugins for custom analysis. For our plugin, we put it in the pre-push, and we had it analyze the code base for code commenting for at least 5% of the file size. For the security token gate, we implement it as a pre-commit hook. So in this example, we have tried to commit a security token, but as you see, we did a git diff, and we are not allowed to make that push. And milestone 3 is deployment. We have set up a Travis CI server to manage the build of a basic application. We have a droplet provision on DigitalOcean to mimic the cluster of DigitalOcean droplets that we can push to. They use Docker files to maintain their running apps. In this example, we have pushed to our GitHub repository. Travis has built it, and our Docker file has ran and exposed the proper ports for our application to run. So now we can check the running processes on our node, and we see that a canary server is up and running. So let's go to our website, put in the IP, and the page still loads. As indicated in our repository, we use the monitoring program to show the request latency and track requests per minute in application. Also, we can change feature flags with the Redis database, and we have implemented a proxy that serves requests to our canary server, 1 out of every 10 requests.
For milestone 4, we implemented the stress monkey. It's important to understand how your application behaves under load. To test this, we handled sending increasing amounts of requests to find when the application breaks down, and the effects on latency. So we set up a basic Node.js application on 3 DigitalOcean droplets behind a proxy server. Our stress monkey then sends an increasing number of requests to the proxy server. We then use Socket.io and a graphing API to display the results of latency and the number of errors from each of the requests. A tool like this can be used to test distributed systems to see where your points of failure are. Now we're going to show a short demo on a computation-heavy endpoint. We're running our dashboard and our training monkey on a local machine to mimic a production environment. The stress monkey takes a URL as a target and sends requests in increments of 50. Once the first batch of requests come in, we can graph the results. It's important to note that the latency does not monotonically increase. The latency does trend upward with the number of requests. Around 600 requests in a burst, we experience catastrophic system failure. We see that connections are being refused and every request is met with an error. We set up our system to run behind forever, so as soon as a failure happens, it starts the process again. Even though the system recovers from failure, it can only respond for a little bit before getting overwhelmed again and failing again. That's why we see these fluctuating lines of errors and latency. One potential point of extension is to have the system notice when this is happening and auto-scale to increase the amount of requests that it can handle. Here are some other things that we thought a system like this could benefit from. Another metric our stress monkey captures is number of requests that exceed a specified latency. We are planning on adding another graph to display these results. Testing using the stress monkey can be implemented during the deployment phase to see if regressions happen. This information could be emailed or texted to developers if it exceeds certain bounds. Since our tool takes a URL as a command line argument, you can actually input the direct address to a node rather than the proxy. This will allow you to test what would happen if all your nodes except for one failed, or if your proxy failed and began sending requests only to one node. Thank you for watching our presentation. Be sure to check out our code at this link below.